All right, AP Environmental Science. This is the second video about the introduction to air pollution that I want to just kind of get through today. I just want to quickly review this from the first video. I talked about the six criteria air pollutants. I told you this mnemonic SPLONK to remember. Kind of a weird word, but kind of helps you remember it. So again, SPLONK stands for sulfur dioxide, particulates, lead, tropospheric ozone, nitrogen oxides, and carbon monoxides. Again, these aren't the only things that can be air pollutants, but again, in 1970, the Clean Air Act identified these six things as like really, really bad for the environment. Okay, so we started talking about the first couple in the first video. I believe we talked about sulfur dioxide, and I believe I discussed nitrogen oxide. So we're going to talk today a little bit about these other four: particulates, lead, tropospheric ozone, and carbon monoxide. And again, it's not in any particular order. They're just kind of random. So I believe we left off here in the first video with nitrogen oxide. So let's talk about carbon monoxide to start off in this video. Now, carbon monoxide, you've probably heard of this before. Again, the chemical formula for it is CO. It's not carbon dioxide. That's a little bit different. Now, carbon monoxide is typically put into the air anytime we burn carbon or we burn hydrocarbons, but it's what we call an incomplete combustion, which means it doesn't burn it completely. If it did, if there was a combustion reaction, for example, then you would get CO2 and water vapor and all those things we talked about in a combustion reaction. But if it's an incomplete reaction, then carbon monoxide ends up being produced. Now, a lot of times when it comes to carbon monoxide emissions, car exhaust is one of the big culprits here, especially cars that were built, back in the 1970s, 1980s, or even earlier than that. A lot of those cars don't have as efficient engines as we do today. So those less efficient engines, they don't burn the carbon that's in the fossil fuel as completely as they normally would, and that forms more carbon monoxide than ever. Now, every automobile is going to produce carbon monoxide, but some produce more than others do. Other issues with carbon monoxide are cooking fires. Remember, a lot of people in developing countries use wood and charcoal and things like that to cook their food with. So if those aren't properly ventilated, then that carbon monoxide gas can build up in the home, and that can be a major issue. The big thing with carbon monoxide is it's a major problem for human health. If it gets into the bloodstream, if you're breathing it in, and it's one of these gases that's invisible, it's kind of odorless, you can't really smell it. But if you get it into your bloodstream, it'll bond to hemoglobin, which is that molecule in your blood that carries oxygen. And if that happens, that means your blood's not going to be carrying oxygen as efficiently as it should. You can pass out, you can black out, you can have like massive headaches, and you can eventually die from that. In developing countries, this is a major issue. In the developed world, you don't hear a lot about carbon monoxide poisoning and things like that. But again, in the developing world where these people are cooking with some of these fuels inside of their home, and the homes aren't properly ventilated, then it can be a major, major issue. So carbon monoxide, make sure we remember that one. All right, lead is the next one. Lead's kind of interesting because not only can it be an air pollutant, but it can also be a water pollutant. In fact, the next unit we get into, Unit 8, is about water pollution, and we will revisit lead. So we'll talk about it as far as a water pollutant as well. But in this unit, we're going to talk about it as being an air pollutant. Again, one of the main sources of lead is burning coal. So again, we burn coal to produce electricity, in this country a lot, and that does release a lot of lead into the air. Some other issues with lead-based paint, especially paint that was that was used to paint homes. Let's say a long time ago. Nowadays we don't really use lead-based paint anymore. But back in the day, let's say 30, 40, 50 years ago, lead paint was a lot more common. And when that stuff gets old, and like, for example, this picture here in the upper right-hand corner, when it gets old and chips, that stuff can become airborne. Imagine scraping all that off and all those particles getting into the air, and you breathing those in. That can be a major, major issue. Um, Another kind of historical problem that we've had with lead was that lead used to be found in gasoline. Today, like you go to the gas pump, for example, and you'll notice on the gas pump it'll say unleaded gasoline. Well, that's because today we don't have lead in our gasoline. But again, this was prior to 1996, especially in the developing world. Um, the, lead-based gasoline was very common, or lead in the gasoline was very common. So every time you burned gas, or every time you started a car engine, you'd be releasing lead into the air. So again, some of the effects of lead, it's a major health issue, especially in children. It impairs the central nervous system, which is the brain and spinal cord. That can lead to learning disabilities, improper brain development in kids. That is a major problem. We'll talk about Flint, Michigan in the next unit. Again, just a little bit of foreshadowing into water pollution, but in Flint, Michigan, if you're not aware of what happened there, they had a major water crisis, a major water pollution issue, and lead got in their water, and it resulted in a bunch of people, including a lot of children, drinking contaminated water that had lead in it. And one of the things that they were really concerned with is the brain development of kids. They've done a lot of studies on their learning, how their standardized test scores and things like that, to see if these kids have really been affected by lead or not, because they were exposed to so much of it. But we'll talk about that more in a couple of weeks. But lead, kind of a major issue. Particulate matter. Particulates are basically larger particles. These are things that can get suspended in the air. A lot of times, again, these are formed by burning coal. A lot of biomass, biofuels, diesel-powered vehicles. I mean, imagine like a big semi truck. Those big exhaust pipes that come out the tops of the semi trucks. All that black smoke and soot that they're releasing, a lot of that has particulate matter in it. Some other issues with particulates: road dust. Anytime cars are traveling on the road, dust gets kicked up in the air. Lots of particulate matter there. Dust from mining operations, volcanoes, dust storms, forest fires. Again, these are kind of some natural things, but there's also some anthropogenic things on this list again, these particles, if they get into the lungs, they can cause some major health issues. They're respiratory irritants. If they get up into the atmosphere, they tend to linger there. They can actually block sunlight. That's not good for plants, obviously. They can also cause haze, which is reduced visibility. These are all problems with these particulates getting into the air and lingering in the atmosphere. The thing about particulates is they do vary in size. And we kind of rank them, I suppose, according to their size. Here, for example, this is called a PM 2.5, particulate matter 2.5. And 2.5, that number represents micrometers. So it's a tiny little unit, but we use it to measure the different sizes of these particulates. So, for example, in this picture here, this is a human hair. A human hair is about 100 micrometers in diameter. Well, a PM 2.5 is only 2.5 micrometers. A PM 10 is 10 micrometers. Now, we start to look at these sizes, because the smaller they are, the more likely they are to get into your respiratory tract, into your lungs, and eventually possibly into your bloodstream, and they can be very problematic. So, for example, we have PM10s. So these are particles that are 10 micrometers or larger. Those things can pretty much be filtered out by your nose. We have nose hairs, we have mucus. That's what boogers eventually turn into. But those things all get filtered, and all that trapped particulate matter that gets into your mucus and is trapped into your nose hairs. Those things just kind of build up in there. Again, we call those things boogers. Kind of gross, but that's not really a scientific word, but we all know what that is. If they're smaller than 10 micrometers, they can really get into your respiratory system and they can cause disease. If they're smaller than 2.5 micrometers, these are typically particulates that are made of toxins. They're really, really tiny, and they can be very problematic and cause a lot of health problems. So just remember that the smaller the particulates are, the more likely they are to cause some type of respiratory illness. All right, tropospheric ozone is the final one here I want to talk about today. Tropospheric ozone is a secondary pollutant. We don't put it directly into the air, but we do put it indirectly into the air. The biggest way that we put ozone into the air, as a secondary pollutant, is through something called a photochemical oxidant. Photochemical oxidants, think about the term photo. That means light, okay? Chemical is chemical, okay? Oxidants means that they're reacting with oxygen. All right, so basically, whenever you put chemicals into the air that typically are made from oxygen or they have oxygen in them, things like nitrogen oxide, sulfur dioxide, these are photochemical oxidants. When you put those into the air, they can react with sunlight. And when they do that, they can actually form ozone. Now, ozone again is really good if it's like way up in the stratosphere because it like blocks ultraviolet light. But if ozone like lingers in the troposphere, which is like where we exist, then it can cause problems. Again, I go back to health issues. You don't want to breathe it in. It can harm plants. It can even degrade our infrastructure. Things that are made of rubber and plastic, for example, that can be a major issue. So we'll talk more about how this stuff forms tomorrow a little bit. But I want to make sure you know that tropospheric ozone is not a primary. It is a secondary pollutant. All right, finally here today, guys, I think this is a nice little list. It just kind of goes through all the different criteria pollutants that we've talked about, sulfur dioxide, nitrogen oxides, carbon monoxide. It gives you the symbols for those, gives you the human-derived sources, like how do those things get into the air, the effects and impacts, then particulates, lead, and ozone, same thing. All right, now I did list here some of the other air pollutants. Again, we will talk a little bit more about these as well. So there are things you might want to look over in addition, but those first six are the ones that I'm really holding you guys responsible for. All right, guys, that is it for these lectures on air pollution, at least the introduction, and I will see you soon. Take care.